In this part of the video, I'm going to go over how to get the axles in place, the sprockets, the retaining ring, and the rivets. I just placed one of each here. You can place multiple, or once you've just placed one of each, you can make copies just with Control C and Control V. And so you can paste in multiple, and that's what I often do. Basically, we're going to have a bearing on each side here, and then on the back we're only going to have a bearing on the outside, because on the inside we're going to attach a gearbox, and somewhere in that gearbox will be the other bearing for the axle. Also, these axles are just for the corners. We'll need a axle for the middle, and we don't have that designed yet because it really depends on what type of gearbox we're going to be using, whether we're going to be using a planetary gearbox or a gearbox that is custom. So these bearings here are designed to hold these rounded hexagon axles. Let's first look at this axle here. So if we look at the axle, it's a hexagon with the vertices rounded off, and the vertices, it's basically a circle, and that circle has a diameter that matches the inner diameter of the bearing, and it happens to be a metric measurement at 13.75 millimeters. And the bearing, even though the model doesn't show it, we have basically the inner race of the bearing, which is this part, spins independently of the outer race, which is this part here. And the balls are behind a cover plate back in here. We'll disassemble a bearing and you'll be able to see the inner parts of it and to see kind of how it works. But it's important that the inner race can spin independently of the outer race. This particular bearing has a flange on it, and the flange will rest on the outer surface of the tube here. So the easiest way to insert these bearings is hit C for constrain, use an insert constraint here, and then zoom in, and you want to basically get either this line or this line. You don't want to get on the curve. After the curve, you can see that there's a little filleted that has a little fillet that has a radius, and we want to make sure that we don't grab the wrong side of that. But basically, we click here, and you can see that it gives us that surface and this direction, this axial direction. And then we can go here and click on this face, and notice we have another surface and the opposing arrow. And if you look over here, it's defaulted to have opposed arrows, and so when I click, you get the flange on the outside, and then we can just hit apply. So I'm going to do that and place all the bearings. It looks like I only have one bearing in the model, so I'm going to click this, go Control C, and then paste that in. And I'm going to just do one side of this for right now. And so let's get the other bearings in. Control or C for constrain, select this edge here, and then select there, apply. And we'll just keep doing that for the remaining bearings on this side of the chassis. We want them on the outside. Okay, and we can rotate this in and go here. Now we do need to put these three sprockets inside, and they fit between the two bearings, and they're designed to fit just between the two bearings with a very minimal gap. And it's kind of hard to see inside there. So one thing you can do is you can select the tube, right click on the tube, and click visibility, and then it hides it. You can see right here it shows this cube here, shows the chassis is not visible. Then we can just do a constrain insert. If you look carefully at the sprockets, and I pass these around class, you can see that the sprocket has a little flange on it. And the reason why it has that little flange that sticks out, and that's to ensure that the other part of the sprocket does not rub against the outer race of the bearing, because we only want it to touch the inner race of the bearing, because the outer race does not spin. So what I'm going to do is zoom in here and just select the inner race. I can select here, or I can select this outer part after the fillet. Here it has a nice sharp edge, so I'm just going to click there and then hit apply. Now if you look carefully, there is a small gap. And so they did leave a little bit of tolerance. You do not need to take the time to center this sprocket in that. If that does bother you that it is not centered, what you can do is measure the distance between this face here, or the face of this face here, and the outer race, and then do an offset by that distance. But it really is not going to matter for us. It's giving me a save reminder. It's a good idea to just periodically hit save as you're working through this. Basically, when you're adding parts, you might have to, it brings up this workspace sometimes, and then you just hit yes to all and then hit OK. And that will ensure that you're getting saved. We can constrain the next sprocket here. And then we can go here. Now the third sprocket, since I don't have the other bearing, and if I constrain it to this bearing, they're not going to be perfectly aligned. And if that bothers you, one easy way to do that is just go constrain, and instead of doing an insert constraint, use the mate constraint, zoom in, choose an axis like this. You can see that we have this axis. And then we can choose the axis of the bearing and hit apply. I'm not done yet, but you can see that this is like this. Then what you can do is ensure that the two face, the face like of this face here, then I can go to the face of another sprocket, are flush with one another. So if I go constrain, flush, and make this. If I zoom in, it's kind of hard to see because the bearing's in the way, so we need to rotate. And in fact, I still can't see it. So what I'm going to do is hide the bearing, right click, go visibility. And so I'm going to go constrain again, go flush. This face is flush with that face. And then they will all be perfectly aligned with each other. And then you can go back to the tube and the bearing. You can go right click and make them visible again. You can see that now they're inside. Okay, for the axle, you're going to click the axle here. Choose a cylindrical face. You can choose this cylindrical wall here. You can choose this cylindrical wall here, just so that it gives you the central axis. What you do not want to do is collect the end and get that point. You need an axis. And then so you can get this axis, and then you can get an axis of the bearing, and then hit apply. And then this can slide in and out like this. What we want is this part of the axle to be flush with the inner race of the bearing. So we can do this, go here, make this here flush with this here, and hit apply. On the outside, the wheels are going to be on the outside, and so they are going to go out here. So this will have a spacer. I will show that in a later video and in class. Then a wheel. Then this is machined here to accept these retaining rings. And so we have this retaining ring, or a snap ring. It's what we often refer to as an external retaining ring. Basically, it takes a tool goes in these two holes and kind of opens it up a little bit, and then it fits into this groove that is machined on the lathe, and you'll make your own custom axles with this groove. And then it springs back and then snaps into that position, and then the axle cannot slide through the bearing. And then we'd stack everything on the other side, and then we would put the retaining ring on the other side. So that's how you get that. We need to do the other end. I want to show you a little nice feature that I use a fair amount. If I select this axle and select with a control click, select the retaining ring and hit Control C, and then I hit Control V, the pasted part has the axle and the retaining ring, and they're already constrained. So that's kind of nice. So what I can do here is just go constrain, make this mated with this. We can still slide this in. One constraint we could do the constraint like I showed before, where this part in here is flush with the inner race, or we know that this face here needs to be flush with the other face of the other axle, and so that's what I'm going to do. I'm going to go constrain, flush this, and flush there. Final thing I want to talk about that we also talked about in class was if you get a constraint that is not working properly or it's wrong, what you need to do is find the actual constraint. And so you find the piece that has a constraint, and then you find it here that it's highlighted, hit the expansion, and you can find the constraint. Notice this has several constraints. That axle has an insert constraint for the actual retaining ring. Then it has this mate constraint for the axis of the axle and the bearing, and then the flush constraint that has this flush with this over here. And if you ever want to change or delete it, you can just right click and you can edit, or you can right click and delete or delete it. Okay? And so you can get rid of a bad constraint that way. And then the rivets, we'll talk about where all of those go, but the way to insert a rivet is grab this edge with the insert constraint and then go to the gusset, click the top, hit apply. We're not filling all these holes with rivets, so don't do that. What you can start with is just getting these 4 here in a line. We'll talk about where to put these in. In class I talked about the reason why there are 2 rows is we're going to have chain inside the tube, and depending on where the chain is at, we need to make sure that the rivets are not interfering with the chain or the sprocket for that matter. And so we'll go over that. So what I'd like you to get to is get the axles on the other side, and then we'll talk in a later video the spacers and the wheels, etc.